let's get started with our next unit, lesson 9.1, page 374. Unit 9, ladies and gentlemen, deals with data analysis and displays. And today we are going to apply what we learned to construct some scatter plots and identify relationships between two sets of data. Our essential question, how can you construct and interpret a scatter plot? Well, that's what we're going to do today. So, ladies and gentlemen, you were a person of character and intelligence. You went to the top of page 374. You were asked to take some notes. You looked at that little tiny paragraph of 2 or 3 sentences and you said, huh? What? I don't get this. I understand. Totally understand. So hopefully you did write down what it said, and that a scatter plot is a graph that shows a relationship between two sets of data. All right, well, now what I want you to do is put your pen, your marker, your crayon, whatever you're taking notes with, put it down, listen and learn, and when I'm done on this page, you can pause and pick up your pen, and you can write it into your notes. So, ladies and gentlemen, some other things to understand about scatter plots. Scatter plots is a graph. It's a graph that's typically graphed on a coordinate plane using quadrant 1. Typically, quadrant 1. There are times that quadrant 4 would be used. And very, very rarely, we could be using all the quadrants, 1, 2, 3, and 4, for a scatter plot. But typically what you're going to see, especially at this level of math, we're going to typically see quadrant 1. We might venture into quadrant 4 every once in a while. But quadrant 1 is where we're going to spend some time. And you know, hey, if we're in quadrant 1, we've been there before when we did proportional relationships. If we're in quadrant 1, we have two sets of data. We call those ordered pairs. So we always had two sets of data. Like we were graphing how many bracelets were made and how much money it cost to make them, or what our profit was when we did make them. All these different types of things. Two sets of data. So we have those ordered pairs, and just like before, those ordered pairs consist of the independent variable, which is usually, that's a very important word, usually the x, where the variable x stands alone and is not affected by the other variables. Ladies and gentlemen, usually, typically, most frequently, you're going to find that the value of x will be increasing. And then we have the independent variable, which again is usually the y. That's a variable whose value is determined by the independent variable. And then with the y, well, the y can do a couple different things. Well, as x increases, y can increase, or y could decrease, or y could just go right and left and just be all over the place. Who knows? It could do everything and anything all at the same time. It could be all over the place. Then we're going to talk a little bit more about that later in this video. Also, ladies and gentlemen, this graph will show a relationship. That relationship is typically defined by identifying what happens to y as x increases. So kind of talking about what we did here, and again, we're going to go more in depth with that in a moment. But right now, you can pause, copy down anything you need to, and then catch us here with the next example. So we're going to start with this example on interpreting a scatter plot. First thing I like to do anytime I'm given a graph is I like to look at it. I like to say, what information is given to me before I even look and read about any questions that are going on. So I can see the title says restaurant sandwiches. I can see that my x-axis is grams of fat and that my y-axis is the number of calories. And then I can see that there's, I don't know, 10, 12 or so dots on there. I'm kind of guessing. And then now I can say that, hey, I'm talking about fat and calories in restaurant sandwiches. That's what I know. And as I read, number 1 says the scatter plot shows the amount of fat in grams and the number of calories in 12 different restaurant sandwiches. So there must be 12 dots on there. All right. Part A says, how many grams of fat are in a sandwich that contains 740 calories? Okay. Well, they told us exactly how many calories, so we can follow our y-axis all the way to 740. Oh, right there, roughly, and go across until we find, ooh, there's a sandwich right there. So from that sandwich, I'm going to come down and I'm going to roughly estimate, and I'm going to say that's approximately 42 grams of fat. You know, again, we're interpreting, we're estimating a little bit because this is not a super accurate graph to the point where we can see perfectly. Part B, how many calories are in a sandwich that contains 33 grams of fat? Well, now we can start on the x-axis. By the way, as you notice, The x-axis is increasing from 0 grams of fat, and it's only showing up to 45, but it certainly could go further. And this time the question asks us to start at 33 grams of fat, so we're going to start right in here, and I'm going to take that up, and voila, there is a sandwich right there, and I'm going to come over this way, and I'm going to say that that's roughly 640 calories. I can see it's not all the way to 650, and so I'm going to estimate about roughly 640 calories. Part C, what tends to happen to the number of calories as the number of grams of fat increases? So here's where we're trying to start looking at relationships, and again we're going to get more in depth in this in just a moment. But as we can see from this graph, we can see that as x is increasing, we can see that y is increasing typically, not always, but typically. So we can say that as x increases, as the number of fat grams increases, because that's what's on x, the number of calories, y, is also increasing, right? So we can pretty much determine that if there's more fat in it, there's more calories in it. Not always, but that's what typically happens. One we can call that is a trend. It's a trend. All right, part D. A sandwich has 650 calories based on the scatter plot. How many grams of fat would you expect? And so based, that means we're guessing, so we're starting right here at 650. I'm going across, and of course there is no dot on that line of 650. So now as I look at that blue line I draw that says, hey, this is kind of going up, somewhere in there, I'm going to pick that spot right there because it's super easy, and I'm going to say approximately 35 grams fat. And again, it's an estimate, and we're pretty dang darn close. Ladies and gentlemen, let's talk about those relationships that can exist in a scatter plot. The first we're going to talk about is a positive linear relationship, and you know that because on a left where the line increases from left to right, we do have a positive slope, and we're going to call that on a scatter plot a positive relationship. Notice it does say as x increases, y increases, and that was just on our example a moment ago. The next one is, and you probably guessed this one, it's the negative one. It's the negative relationship because as x is increasing, what's happening to y? Yep, it's decreasing. We have a line that goes down from left to right. Just the scatter plot goes down just like our line did when we were graphing, and so we call that a negative relationship. Our next relationship is called no relationship, or back up, rewind. It is a non-linear relationship, and as you can see, the lines are together, but they're not really in a line. They're kind of curved, and that's not the only curve that can happen. It could actually curve the other way, or it could start at the top and curve down, or it could also start at, where am I saying here? There is another one on there. I'm looking, I know, heavens. So it can go curve up, it can curve down, it can go this way, or it could go this way. That's what I'm looking for. I know it's kind of sloppy, but there's 4 different types of curves that you could have, and they are examples of nonlinear relationships. And then, of course, we do have the no. This is why I didn't want to say that the last one. No, because this typically defines the word scatter. It is everywhere. Dots are everywhere. There is no typical pattern, no relationship that says, hey, as x increases, what is happening to y? It is everywhere, and so there is no relationship. So we're going to use what we just learned on these 4, and we're going to describe the relationship that is happening in this graph, and then we're going to talk about some other things called outliers and gaps and clusters, and we'll define those as we go. So this is what is our restaurant one, and of course we're going to call this a positive linear relationship. Because as we can see, as x increases, y increases, we have a positive linear relationship. I'm going to erase my red line, ladies and gentlemen. And as you can see, there is no obvious, that I could use to actually point out to you, no obvious outliers, gaps, or clusters. But we will have some, and we'll talk about it. All right? So this one shows a positive linear relationship. Our next one on television size and price. So it's saying, hey, as the size of the television increases, as x increases, what's happening? As x is increasing, what's happening to y? And again, it looks like y is increasing. So again, we'd call this positive linear relationship. And I'm sorry about my spelling there, but that's what it is. Positive linear relationship, ladies and gentlemen. Positive linear relationship. And then we're going to look. So here I can show you outliers. This one right here is pretty much out on its own, all by itself. So we do have an outlier. And it is located at 70, and I'm going to have to estimate this a little bit, 70 and about 2,200. So it's an outlier, a 70-inch TV that only costs 2,200 bucks. Okay. We also have a gap in here. Notice that there is a gap. There's a gap between this value of 500 and this value of 1,500. So we have a gap in the price. So we have a gap between $500 and $1,500. All right? Could you have a gap in the television size? You certainly could. But they don't have one on this fact, so just wanted to know that gaps could exist on the x-axis and they can exist on the y-axis. And then we do have a cluster. A cluster is, you're going to have more than two. So you can see that there's a cluster right here. So you have a cluster, and the cluster is more on the money part because it's a little bit more spread out on the size part. So I'm going to say a cluster at roughly $500. That's what it looks like to me. All right? So this one does have positive linear. There's an outlier, there's a gap, and there's a cluster. And our last one, the age and pets owned. So a person's age and the number of pets that they owe. And as I look at this one, wow, there are dots everywhere. So this is going to give me a no relationship. And of course, there's no obvious gaps. Clusters or outliers. Yes. All right. So that's that, ladies and gentlemen. We do have our first quick write, and that first quick write is this one right here. You already have it in your notes. I put it in there for you to make it easy today. It says identify the relationship between the data, identify any outliers, gaps, or clusters, and have some fun with that. And of course, take a quick break and come back and see me for the next video.